Assalamu alaikum. How are you, dear students? Welcome to the channel, The Physics Gurus. This will be the next episode of the series of definitions of O-level and IGCSE physics of the syllabus 2022. In episode number 4 or in episode number, you can say 3 plus 1, that is equal to 4. So in part 4, we will discuss the definitions related with the unit number 7, pressure, and related with the unit number 8, that is energy, resources, and transfer of energy. So let's start with unit number 7. The very first definition of unit number 7 of the pressure is, that is the force acting per unit area perpendicularly is called as pressure. So the formula of pressure is equal to P is equals to F over A. P stands for pressure, F stands for force, and A stands for area. Since the formula is P is equals to F over A, so its unit will be Newton and the unit of area will be square meter. So the unit becomes Newton per square meter, or its alternate unit is pascals, which is represented by capital P, small a. So we can write the unit of pressure is equals to Newton per square meter, or PA. Now from this equation, we can see that pressure and force are directly proportional to each other. It means larger the weight, larger the force, larger will be the pressure. Smaller the weight, smaller the force, smaller will be the pressure, while pressure and cross-sectional area are inversely proportional to each other. It means that when cross-sectional area increases, pressure decreases, and when cross-sectional area decreases, pressure increases. So what we have concluded from here, that force and pressure are directly proportional to each other, and cross-sectional area and pressure are inversely proportional to each other. Then another definition which covers the unit number 7, that is pressure, and the definition is barometer. Barometer is device which is used to measure atmospheric pressure, and it is just like this, an inverted tube filled in the mercury trough, and then this side represents the atmospheric pressure. While the definition of manometer, a device which is used to measure pressure difference, and it will be just like this. We have a U-shaped tube, and from this side we have provided the gas supply, due to which the liquid on the right side of the tube will moves up, while the liquid on the left side will move down, because gas pressure is larger than the atmospheric pressure, and here the pressure will be due to the depth of the liquid. So pressure of gas is equal to atmospheric pressure plus pressure due to the liquid. So in this way we can find the pressure difference of the two gases. Then here becomes the formula of liquid pressure. Liquid also exert pressure, and liquid exert pressure equally in all direction. And in order to find the pressure exerted by the liquid, we will use the equation P is equal to rho GH, where this is the symbol rho, and it represents the density. G stands for gravitational field strength, and H stands for depth. It is not the height, it is the depth, like this. It will be always made from the top surface to the point where we have to calculate the pressure. So this will be called as depth, and it is represented by H. So the formula of liquid pressure is will be equals to P is equal to rho GH. Never ever read it like P. P is equal to PGH. No, P is equal to rho GH. And then formula used in hydraulic press where we can apply the Pascal's law will be equal to F1 over small a is equal to F2 over capital A, and the diagram will be like this. If we are having two cylinders, one is of the larger area and the other is of the smaller area, and we have applied the force from here F1 on the smaller area, and then there is a liquid, and then this will be the definitely of the larger area, and F2 will be exerted in upward direction. But one thing will be keep constant throughout the liquid, that is the pressure. So pressure on the both sides will remain same. So by comparing their pressures, we can formulate the formula F1 over small a is equal to F2 over capital A, where small a represents the cross-sectional area of the smaller piston and capital A represents the area of the cross-sectional area of the larger piston. So let's move towards the, rather there is one more definition which is unfortunately missing over here, and that is the definition of Boyle's law. In that we have studied that pressure and volume are inversely proportional to each other. Larger the pressure, smaller will be the volume, smaller the pressure, larger will be the volume. And from here we can see that the product of pressure and volume is the constant, and for two different pressures and two different volumes we can write P1 V1 is equals to P2 V2. So in this way we can develop the equation P1 V1 is equal to P2 V2, and provided that one thing is very important, that temperature is kept constant. Okay, now let's move towards the definition of unit number 8, that is energy resources and transfer of energy. In other words, work, power, energy. Okay, so what is the definition of energy? Ability of a body to do work is called as energy. And then here comes the second definition, that is law of conservation of energy. Energy neither can be created nor destroyed, but it can be converted from one form to another form. So it can be converted from one form to another form. Or energy neither can be created nor destroyed, but total energy of the system remains constant. So you can write any of the definitions. Then very important and very famous definitions is over there. Kinetic energy, the energy stored in the body due to the motion. Whenever body moves, it will possess the energy, and that energy is called as kinetic energy. And the formula of kinetic energy will be equals to half mv square, where m stands for the mass and v stands for the speed, and the unit of kinetic energy will be joules. If a body is moving with constant or uniform speed, then kinetic energy will be 0. This is a very important point. In many MCQs, this point is being asked in the question, or this point is given in the question. So if it is given that body is moving with constant speed, then never ever select the option which carries kinetic energy. Then here comes another definition, gravitational potential energy or potential energy. So the energy stored in the body due to its position, and in general we will always consider the vertical position or vertical height, and that energy is called as gravitational potential energy. And the formula of potential energy or gravitational potential energy is equal to mgh. M stands for mass, g stands for gravitational field strength, and h stands for height, vertical height. Like this, this will be considered as distance, and this will be considered as height. So in the formula of potential energy, we will consider this distance, and definitely this is the type of energy, so its unit will be also joules. So unit of kinetic energy and both potential energy will be joules. Then renewable energy resources. The energy resources which can be used again and again, or which cannot run out, or which can be replenished, are called as renewable energy resources. For example, wind energy, solar energy, geothermal energy. So all these are the examples of renewable energy resources. Then here comes the definition of non-renewable energy resources. So the energy resources which cannot be used again once used. So once they are used, they cannot be reused, or the energy resources which run out, which cannot be replenished. For example, coal, energy obtained from coal, oil, or gas are the sources of new non-renewable energy resources. Then here comes the definition of work. The product of force and distance covered in direction of force is called as work. So its unit will be joules. Never ever write the unit of work Newton meter, although its equivalent unit will be Newton meter, but we have specified the unit Newton meter to the moment of force. One important point, that if force is acting in downward direction and distance is covered like this, that they are making an angle of 90 degree, then in this case work done will be 0. Or if a body is moving in the circular path, then again work done will be 0. Why? Because there is an angle of 90 degree between the force and the direction of motion, and there will be no energy existing over there. So work done will be 0 when body moves in a circular path. Then another definition is there, and that is the definition of power. And the definition of power is very easy. Rate of doing work is called as work, power, or work done in the unit time is also called as power. The formula of power is equals to, power is equal to work over time, power is equal to energy over time. Sometimes we can write power is equal to kinetic energy over time, and sometimes we can write power is equal to gravitational potential energy over time as well, because kinetic energy and potential energy are the types of energies. And the unit of power is watt, and it is represented by capital W. Then here comes the last definition related with the unit number 8, and that is the definition of efficiency. The ratio of output energy to input energy is called as efficiency. So the formula is useful energy output over total energy input. And if we want to calculate the efficiency in percentage, then we have to multiply these two values with 100. If powers are given, then the formula will be useful power output divided by total power input. And if you can say work is given, then we will write the formula useful output work divided by total input work. So best of luck to all of you for your exams. If there is any question, you might write that question in the comments of the video. Thank you very much. Assalamu alaikum.